Good morning, afternoon and evening, everybody. Thank you very much for the opportunity to speak this afternoon, and hopefully I can give you some insights into the Fusarium Wilt TR4 situation in Australia. I would point out that this is a significant body of work from a range of organisations, not just myself, obviously, a much bigger body of both research and industry and regulatory organisations. So probably the first thing is a little bit about Fusarium wilt of bananas in Australia. We're here to talk about TR4, but Australia has a number of different strains of Fusarium wilt that affect bananas, and it's important in any of the consideration of the works that we do that we're not just focusing on, say, genetic resistance to TR4. We also have to have resistance to things like race 1 VCGs, as well as subtropical race 4 VCGs. I guess the key thing here is that TR4 arrived in Australia in 1997. Actually, if I just go back on, the other one that's actually important to understand, I guess, is Australia runs as a federal model of government, and that's important because for external quarantine issues, the national government is responsible. But once disease or pest become established, the management of those then fall to the individual states, each of which has its own government and parliament, and often departments of agriculture. So the response for TR4 in the incursions within Australia have been managed at the local level, at a state level. So in 1997, TR4 was first detected in the state, or the territory called the Northern Territory. It rapidly moved through the small industry there. It was a very small component of the national industry. The disease probably wasn't found as early as it should have been, and within 6 years, most of the productive commercial farms were infected. There's only now one commercial farm producing Cavendish left in that region. In 2015, it was detected in the major production region in Australia, and this region produces 95% of the national crop. Now, as a banana producer, Australia's very small in the scheme of things. It's an entirely domestically focused industry. But this was quite a devastating blow. Excuse me. I guess one of the key aspects about Australia's TR4 response is that it sits essentially supported by three key pillars. Regulation, strong regulation. So within Queensland, within the state that I work in, and where the incursion in 2015 was found, we have some very strong quarantine and biosecurity laws that we can call on to allow us to manage and regulate incursions of new pests and diseases, such as TR4. The banana producers are a cohesive industry represented by a peak industry body in Australia, and that's actually been really crucial in terms of responding collectively to the threat. And the other key pillar here is research that has been focused on implementing key aspects that are identified through relationships with industry and to support regulation. So what do I mean by that? So how does research, development, extension assist? When we first had our incursion, we had one infected farm and 280 non-infected farms. So there's a prevention requirement there, which is about how do we stop the disease spreading to farms that aren't currently infected. There's also a need for a response in terms of how do we contain the disease on the current infected farms. And then we need a longer term response, which says that at some point the disease is going to become more widespread. This is the experience internationally. And so we need to start to prepare for how do we live with the disease. So the response is different for the different scenarios, but in the initial stages, we focused very much on the prevention requirement, and that was about science-based biosecurity. So the majority of our farms were not infected and remain uninfected. We needed to start to have industry understand the disease biology, how it spread, and how that applies to their farming practices. We ran a series of very well received biosecurity planning workshops, which outlined a little bit about the disease, but it was more than just providing information. It was actually a process of individual farms working on their own individual property as far as developing plans. We were required early on to undertake some research and development to support the biosecurity. So, for instance, which are the best sanitizer products? How do we manage them effectively? How do we plan for biosecurity? What are the best practices? There was significant effort also placed in attempts to find early detection methods beyond human surveillance, and to date, none of those have proven to be any more reliable than human surveillance, unfortunately. But early detection is a real key. And in the Queensland scenario, the fact that we have now, 5 years after the incursion, have maintained it on 5 farms, which are all very physically closely located. And so far, a total of 90 infected plants have been recorded. So that's a real testament to the fact that we probably found this disease early, courtesy of the initial producer who reported it, and then very intensive ongoing surveillance provided by the government biosecurity agency, as well as regulations that prevented them from undertaking practices that risk the movement of the disease to other properties. We also put a lot of emphasis on communication and extension. We produced a best management practices guide written for growers, and this has now been turned into an online resource that allows growers to undertake a self-assessment of their current practices, see how they currently stack up, provides opportunities to develop improvement plans. We produced video resources that are online for identification and understanding the disease, security practices, and we also had regular industry extension activities to keep people updated with the latest research results. In the containment space, one of the key things that we worked on early, and this came out of, I guess, experiences that we'd learnt in working in Asia, is about how you contain that initial inoculum. Infected plants are a very high risk. They produce a lot of inoculum, so we need to be able to deal with it. And in Australia, we don't have the luxury of burning with rice hulls or other material such as we've seen in the Philippines. So a lot of work was done by my colleagues looking at effective disinfestation methods, and the one that we have used and continue to use under protocol is high rates of urea to produce ammonia gas, which research undertaken by one of my colleagues who's online, Wayne O'Neill, had sort of shown was able to significantly reduce the amount of inoculum, viable inoculum in both the soil and in the pseudostem material of infected plants. Now, unlike most other places, we are not trying to replant in this site. These individual sites are currently under quarantine and not allowed to be planted back again. But this has been, I think, a key part of why we've managed to contain the disease, because we've been able to effectively deal with infected plants once they've been identified. There's also been a lot of work done on managing inoculum levels by identifying alternative hosts, and there's an excellent booklet produced by one of my colleagues, Dr. Tony Patterson, on host status for a range of the Fusarium Wilt strains for, I think, 50 weed species. So they were the sort of things that we'd done to contain the disease and to try and prevent it spreading onto individual other uninfected properties, or try and slow the spread on the existing properties. The third strategy was really about preparing for a future where we would have to live with the disease, and recognising that that was going to take a significant amount of time and research investment. So in essence, we looked at good biosecurity in containing the spread of the disease as buying time for the industry to try and come up with an integrated production system that would allow us to live with Fusarium Wilt TR4. And the basis, the foundation for that is really predicated on having some resistant genetics. So we have worked closely with international breeding programs that have been happy to share material with us under stringent conditions. We have screening sites in the Northern Territory where we're allowed to work directly in the field with this disease. And we've probably developed some excellent research activities and protocols for undertaking this work. The key man or key person in this role up there, Charles Mintoff, is also on the line listening in on this presentation, and he's done a sterling job up there in terms of screening not just cultivars but also important parental breeding lines of a number of international breeding programs. So we're looking to international programs to see what material there is that has resistance. We also have undertaken a pilot study which is essentially trying to develop some of our own material through a mutagenesis approach using ionising radiation. Now, this is probably slightly different to the approach that's being taken by the IAEA program in the sense that we, rather than trying to take a susceptible cultivar and make it resistant, we were starting with resistant cultivars and trying to make them more productive or overcome some of those quality and production characteristics that restrict their current application commercially. As a part of this, we have a network of regional screening trials. Only one of these has TR4, that is the one at the coastal plains in the Northern Territory. That's about 12 degrees south of latitude. The main production region is in the humid tropics in the northeast. We assess many of the same cultivars there for their production characteristics. And in the subtropics, we also have another trial which is looking essentially at resistance to other strains of Fusarium Wilt, particularly those we would characterise as race 1 and subtropical race 4. Because without race 1 resistance, anything on the east coast would be probably impossible to produce commercially. We've undertaken, as I said, a small mutagenesis program, effectively taking material that we've identified previously with good resistance and trying to make it more productive. We've had a look so far at 4 Cavendish and 1 non-Cavendish line, and that's the Fear variety, Fear 01, which is known as Goldfinger in Australia. So far, 2 of the Cavendish lines have produced acceptable improvements that we're looking to take to a second stage of assessment. The Goldfinger material, so in the 2 Cavendish lines, we were looking for improved production characteristics, so fruit length, the agronomic cycle, the phenological cycle, so the time from planting to harvest. These are often very slow in the existing TR4 resistant or tolerant lines. We're also looking for plants with a shorter plant stature. So we've identified lines that potentially meet those characteristics and need more intensive. In the Goldfinger space, we're looking at improving the eating quality. Goldfinger has many admirable qualities. Unfortunately, its eating quality is not one of them, but it is highly resistant to both TR4 and other races of Fusarium Wilt, as well as being tolerant of a range of abiotic stresses and resistant to a number of other pests such as nematodes and weevil borers. So we're interested to see if we could produce a better quality, eating quality Goldfinger. And we currently have 20 selections in stage 2 assessment. I guess the other pillar to the living with Fusarium Wilt is about dealing with inoculum. So we realise that we need resistance. However imperfect that may be in market acceptable cultivars, we also need to be able to manage inoculum, because even Goldfinger, even Fear 01 will die under heavy inoculum. In our current trial in the Northern Territory, we have Goldfinger plants dying where the inoculum is quite high. So ongoing, we need to understand, I guess, the role of the soil microbiome in how it influences suppression of inoculum development. And then how farm management practices like fertiliser management, ground cover management, etc., influence the microbiome. So this is ongoing work, and there's a lot of really important work being done there by Dr. Tony Patterson and Dr. Paul Dennis at the University of Queensland. But it's very much in the early days, and I think it's going to be a very significant component of an integrated system. But I would simply say that I think whatever the future looks like, it is not going to be what it looked like in the past. As Tony always says to me, change is difficult, but to not change is fatal. And so I'll just finish, Jakob, by just saying that the key thing in all this is it is a multidisciplinary effort. This photograph here at the top represents a meeting of all the people working in Fusarium Wilt research in 2017, I think. And we have everyone in there, from agronomists to extension officers to pathologists to geneticists. And everyone plays a really, really important role in this. And you can't do it alone. No single discipline is going to find an answer to this. It's a very complicated problem, and it needs a solution that addresses that complexity. Thank you.
Thank you, Stewart. Interesting paper. I think you covered from biosecurity to containment, resistant varieties, and of course, the last, inoculum and microbiome. Very interesting.